In this video, we're going to introduce the fundamental concepts of kinematics. Kinematics is the study of moving objects. So something like throwing my pen in the air and catching it, or kicking a soccer ball, or the motion of a car as it moves down the road. Any of these things can be described using kinematics. And in this video, we're going to set up the fundamental ideas that we need. The first thing that we should be able to do if we want to talk about the motion of a pen being thrown in the air is that we should be able to talk about where that pen is. We call this position. Position is just the location of an object at any given moment. Imagine that you want to tell your friend exactly where the pen is at this moment. Right? You want to be able to describe to your friend exactly where this pen is. The best way that, as physicists, we've found to do this is to give the pen's location relative to some reference point. So you can imagine that I am standing here and I am holding this pen. That is my completely life-sized pen. And if you wanted to tell your friend where the pen was, you could tell them, for example, the height of the pen off of the ground, right? You could say, at this moment right here, 38 seconds into the video, the pen is 2 meters off the ground, right? At that point, your friend would at least know one variable of where the pen is, right? And then you could say, well, the pen, if this is the blackboard, right? The pen is some distance from the blackboard. So then your friend is able to know, well, it's this far off the floor and this far from the blackboard, right? And then you could give the location in the third dimension as well, like how far is it from, say, the wall over here, something like that, right? So if we want to talk about position, we need what we call a coordinate system. A coordinate system gives us the reference points where we can locate an object in space relative to the things around it, right? So our coordinate system needs some kind of an origin, right? Someplace that we call position 0, and we measure all of our heights and distances from that position. So maybe in this one, our position 0 is here, at the kind of corner of the wall where the blackboard meets the floor, right? And so then you could tell your friend, well, if you start at the corner of the wall where the blackboard meets the floor, you have to move over some distance d and then up a height h. So maybe you move over 2 meters and up 1 meter, and then you will find the pen, right? So your coordinate system needs an origin and it needs directions. That is up, down, left, right. And in general, we associate directions with either, say, x and y coordinates, right? So you could say, I need to be able to move in the x direction, and I need to be able to move in the y direction. We'll only use 2 dimensions in this class, though you could use x, y, and z to have 3 dimensions. And we associate positive and negative with these directions. So for example, you could say that in this coordinate system, moving up is the positive y direction, and moving to the left is the positive x direction. So you would say, okay, to get to the pen, I need to move to the left d distance, say 2 meters, and I need to move up 1 meter, which I've called h here. So h is 1 meter, for example. So then these positive signs, you can say, okay, that's moving positive in the positive x direction for a distance of d, and moving in the positive y direction for a distance of h. And of course, then you could have negative y and negative x. It doesn't actually matter what you choose to be positive and negative here. You just have to pick one and stick with it. Okay, so whenever you have to talk about a position of an object, the first thing you need is a coordinate system where you can locate the position of that object in space. Now let's talk about a simpler example of locating objects and allowing objects to move in only one dimension. So imagine we have a person, and this person can move back and forth along our axis here, but they can't move up or down or in or out of the board, just for simplicity. Okay, so we would eventually like to be able to describe this person's motion, right? We're going to let them walk back and forth. But first, we should be able to describe their position in an easy way that we can keep track of. So what we're going to do is we are going to describe their position as a vector. So a vector is a mathematical object with magnitude, which also just means size, and direction. So we're going to describe this person's position using a vector, using a mathematical object that has both direction and magnitude. Okay, well, I already have my coordinates set up here. So what I'm going to do is I'm going to create a vector that points from the origin to the place where the person is, right? And we can draw vectors as arrows. The arrow has some length that tells us about the size of our vector, and then the vector has some direction. So I'm going to call this r sub I vector, which is the initial position. The I stands for initial. So this would be our initial position, where I is initial. Okay, so that is if you were at the origin and you were looking for this person, right, you want to end up where they're at, you would start at the origin and you would go to the left along my vector for 1 meter here. So now let's see how we can write this vector as a mathematical object. So r sub I is equal to 1 meter in the negative I hat direction. All right, so there's a lot of just mathematical notation that was just introduced here, so let's go over it all. All right, 1, when I put an arrow above a variable, that indicates that it's a vector. So anything that you see with an arrow above it, that indicates that the object is a vector and has a direction associated with it. Okay? I is a subscript indicating initial. The 1 meter is your magnitude. That's the size of your vector. In this case, it tells you how far do you have to go from the origin to get to your person. And this here is called a unit vector, and it indicates direction. Okay, so the two parts of this, one, the minus says I need to go in the negative direction, and I is in the x direction. So if you see an I hat, that means you're moving in the x direction. So this thing is pronounced I hat, because it's wearing a little hat. And it means that it is moving in the x direction. So, what this says is the r initial vector, that is my initial position. To get there, I start at the origin, because I'm always measuring my position from the origin. I walk 1 meter. In what direction? I walk in the negative x direction. That's what the negative I hat says. I can rewrite this, and I typically will. Instead of keeping the minus sign with the I hat, I will normally write r initial is -1 meter I hat. And this just tells us, it's just a cleaner way of writing it, to not have the minus sign stuck in there with the I hat. But this and this mean exactly the same thing. To get to my initial position, I had to walk 1 meter in the negative x direction. Now let's say that we want to allow our person here to move along our axis. So let's say that at some later time, they are here. So this is my final position. My final position vector, which I will write as r sub f, is going to be 2 meters in the I hat, or x direction. So to get to my final position, I start at the origin and I walk 2 meters in the x direction. And then, of course, I have my r initial vector, which is -1 meter in the x direction. Okay, now that we have our person moving, we could try to think about what is their velocity. So first we should define what velocity is. So velocity is a speed with direction. So a speed, for example, could be 10 miles per hour, or 30 meters per second. Those are both fine speeds. A speed is just a number. In physics, we call just numbers scalars. They are a magnitude, but no direction. So, if you tell me that you are traveling down the highway at 50 miles per hour, I have no idea what direction you're going in, right? You could be going west, east, north, south, anywhere. If you want to tell me your velocity, you have to tell me the direction along with that speed. So your velocity would be 50 miles per hour north, right? Then I know, okay, you're driving at 50 miles per hour, that is your speed, and I know the direction that you're traveling in north. So, if I want a velocity, I need a speed with a direction. And we want to find out about the velocity of this person. We want to know what speed they were going at and what direction they were going. So, the generic equation that we are going to use to start with for velocity is that the velocity, which is a vector, so I put an arrow above it. Note that the direction of this arrow has nothing to do with the direction of that the person is moving, or the direction of your vector itself. This arrow always points to the right, no matter where the actual vector points. This is just a mathematical symbol to tell you that this is a vector. Okay, and we define our velocity to be the change in the position divided by the change in time. So mathematically we write that as delta R divided by delta T. So as a note, this triangle is the Greek letter delta, and it means change in. So whenever you see delta, just replace it with change in. So this is the change in my position vector divided by my change in time. And we can always define this change in variable as the final value minus the initial value. So that is to say that delta R is the final value of my position minus the initial value of my position. And my change in time is the final value of my time minus the initial value of my time. Okay, so let's imagine that I see the person here, and then I close my eyes for 10 seconds, and then 10 seconds later I open my eyes and the person is here. So they have moved from here to here in 10 seconds. So in that case, my delta t is 10 seconds. That is my final time when I open my eyes again. Minus 0 seconds, that is the time when I first saw them. In general, we're always going to start the clock at the point where we start taking a measurement. So our first measurement was when I saw the person at 1 meter here, or -1 meter here. So I'll call that t equals 0, and then 10 seconds later, we will say they're at 2 meters. So that's my delta t is 10 seconds. And my delta r is going to be 2 meters I hat minus -1 meter I hat, which is 3 meters I hat. The direction, you can only add things together that have that go in the same direction. Like this. So I can say 2 meters plus 1 meter equals 3 meters in the I hat direction. If you have multiple directions, you have to be a little more careful about how you add vectors in different directions, and we'll go over that later on. Okay, so my delta r is 3 meters, so my velocity is going to be 3 meters I hat divided by 10 seconds is going to be 3/10 meters per second I hat, right? My units are meters divided by seconds. My direction is I hat because it's a vector, it needs a direction. And I moved at this rate. I moved 3 meters every 10 seconds, right? You could turn that into a decimal if you want. It doesn't really matter. So I would draw my velocity vector as being to the right. And again, the length of this arrow, which is my actual vector, notice that this arrow above the V doesn't indicate direction at all, but my velocity vector itself points to the right, and this has units of meters per second, so I can't really compare its length. That is, for my R final vector, it literally spans 2 meters from 0 to 2. It points from the origin to that, so it should be 2 meters long. But my velocity vector has units of meters per second, so I shouldn't draw it 2 meters on here because that's a distance. All we can do here is just say, well, if I had a velocity vector that was 1 meter per second, it should be half as long. And if I had a velocity vector that was 4 meters per second, it should be twice as long. You can only compare lengths of vectors that have the same units, right? So I can compare velocity vectors to other velocity vectors. I can compare position vectors to other position vectors, but I can't mix and match that. Okay,